Hello, this video we're gonna use water as an example to go through the throttling device. In the last video, we look into refrigerant 134 goes through the throttling device. We discover the pressure drops down. However, the most terrific thing happens is that the temperature drops tremendously. But how about if we have water going through this throttling valve? What happens? And this is actually quite a clever way for us to determine what's the quality by using this throttling device. So for example here, they said this is coming as saturated steam, and it's actually a liquid vapor mixture. It's a quality. So we don't know what's the quality, but we know the pressure is 0.4 megapascal, and it's being throttled to a lower pressure as 0.1 megapascal and with a temperature as T2 100 degrees Celsius. So they want us to find out what's the quality of it. Like I said, it's very ingenious for them to use the throttling process in order to determine the quality, right? Because we can totally measure the pressure coming and pressure leaving, and also we can measure the temperature. Then we can figure out how much quality there is at the beginning. So now let's take a look. How do we do so? So the first step is, since we know the two property for the final, P2 and T2, 0.1 mega and 100, and this is water going through, then we can find H2, right? So let's go to our table, steam table. We don't know what region this is, and is that superheated or mixture? So we're going to find out. So the way to find out, we're going to go to table A5. We're going to find out what's going to be the saturated temperature at 0.1 megapascal. Okay. So that's a table A5. Okay, 0.1 megapascal, that's going to be 100 kilopascal, and the saturated temperature is 99.61. Okay, and our temperature is about 100 degrees Celsius, exactly 100 degrees Celsius. So that means our T is greater than Tsat. That means it's going to be as superheated vapor. So if it's superheated vapor, that tells us we're going to go to a different table. We're going to move down to table A6. So what are the two properties? We know the pressure, 0.1 megapascal. So let's go to 0.1 megapascal. And temperature is 100. We want to read H. So that's our H value, 2675.8. 2675.8. That's going to be our H2 value, and that's going to have a unit of kilojoule per kilogram. H2 is equal to this value. Okay. That's our first step. Now we know throttling device H1 is equal to H2. Then we can therefore find our H1. It's the same value. Knowing that, we can come back to write down H1 value right here, because that's going to be our second property. Not only we know the pressure, we also know the enthalpy. Now it's time to figure out the quality. So very likely with these two combination, we know this is going to be a mixture because they ask you the quality. So the first thing we want to find out is what's HF and what is HG or HFG. Okay, at 0.4 megapascal. So we're going to table A5, our pressure table. We set a 0.4 megapascal. So our pressure table, we're going to go to table A5. 0.4 mega, that's going to be 400 kilopascal. This row. Then we can find our HF and HFG. Our HF is 604.66 and our HFG is 2133.4 kilojoule per kilogram. Okay, so then we can go ahead solve our quality. That's the last step. Because we know quality equation is this H minus HF over HFG. Our H is 2675.8 minus HF 604.66 divided by HFG 2133.4. And then with that, we can calculate our quality. The answer is 0.971. Okay. So we'll wrap up the for this problem. All right. So we're done with throttling on device. So next video we'll be looking at mixing chamber. All right, see you then. Bye.